Hello friends, my name is Ajay and welcome to part 3 of the Unit 2 AP Computer Science A in-depth review on primitive types. This is going to be going over the practice test that I created, which will be in the description. It's been in the description of both part 1 and part 2, and it will be in the description here. I greatly recommend you do it. It's going to be 20 multiple choice questions and 1 FRQ. It is very good practice for maybe, if you have in-class tests or if you're preparing for the AP exam. I greatly recommend that you do it. So without further ado, let's jump into it. So over here, this is number 1, right? And so basically what I'm going to do is I'm going to go through and I'm going to explain every question and why the answer is correct. So the first one is Java is known as an blank or known as a or as an blank oriented programming language. Remember, this is the first thing that I wrote on the notes page. Very, very important. Java is known as an object-oriented programming language. No other answer is acceptable. Okay. Now, number 2, complete the analogy. I think I forgot this word in in the first part. I was kind of wondering what it actually meant, I forgot when I was talking about blueprints and houses and stuff. It was actually part of that video. I think I forgot the word, but it is analogy, all right? So complete the analogy. Blueprints are to houses as blank are to blank. Well, blueprints specify how houses are going to be made, what they may, what properties they may have, what they may do, how they're created. So therefore, this is a perfect thing for classes, right? Classes are very similar to blueprints in that way. They are kind of they are the backbone of what helps to create objects, right? So blueprints are to houses as classes are to objects. So D is correct. Now, number 3, in Java, objects A do the actual work, 2 are derived, created from classes, C are limited to only 100 per program. Objects definitely do the actual work in an object-oriented program. That was also specified in part 1 in the notes. And then they are derived from classes, basically meaning that objects are created using what is specified in a class. And then are limited to 100 per program. That is not correct. You can technically have how many you want as long as your computer and your program can handle it. Therefore, 1 and 2 is correct. Okay. Now, number 4, it asks what part of a Java class defines the behavior of a class, mainly what it can do. Now, this should be behavior of a type, really, because behavior of a type, what it can do. This is the key word, even if you didn't know, even if this was the way it is, right? What it can do. Your options are fields, constructors, methods, and main methods. And the correct answer is methods. Methods define a physical action, right? Something that it can do itself. Fields specify actual, descriptions, right? Descriptors. Remember, I still have this, right? The car. It talks about the physical properties. Rather, a method talks about the actions it can do. All right? Now, number 5, which of the following are true about constructors of a Java class? 1, constructors construct classes. Yeah. It's in the name. Constructors help to, construct classes. Do they construct classes? Right? See what happened there? What happened there was something that a lot of times people may do, either AP exam or teachers, they may change words a little bit. Constructors, yes, they construct, but they do not construct classes. They construct objects. Therefore, 1 is not correct. Okay, they construct objects, not classes. 2, constructors initialize fields of a newly created object. That is true. They specify those initial properties. 3, constructors have the same name of the class they're in. That is definitely true, right? Remember the example with the taxi. The constructor name was the same as the class name. Therefore, 2 and 3 are both correct. Moving on to number 6, class names usually begin with a uppercase letter or a capital letter. Always, right? That's standard convention for reference types. And then 7, classes blank in Java. So you have defined a type, do the actual work. Remember, do the actual work is for an object. So that's not correct. Convert Java code into binary for a computer to understand. We did not necessarily talk about this, but this is a compiler. So it's important that you know this is a compiler, but that's not what a class does. And then defines what an object knows and can do. Right? Knows and can do. That is also technically, again, you have to read the wording. Just define what a field knows and what the field can do. Fields cannot do anything. Objects do things. So object knows and objects can do. Classes define what an object knows and an object can do, not what a field knows and what a field can do. So that's also incorrect. A is correct. It defines a new reference type. 8. When a method does not return anything, it is considered. Correct answer is void. A lot of people forget between static, non-static versus void and returning. Void does not return anything. Returning returns something. All right. So therefore, void is correct. Number 9, we did not talk about APIs, but what do APIs stand for? This is something that that I put in here because sometimes it is asked. The correct answer is Application Program Interface. This is one that is not necessarily, I did not talk about it in the notes, however your teacher may have went over it, so I just included it anyway. This is something that is on the actual course description, and it's something that you should probably know. That's why I included it here, just that just so that it refreshes your memory a little bit. Number 10, which of the following are true about string objects? You have string objects are immutable, meaning that their methods do not modify the object itself. Okay? Then you have string objects can be concatenated together using the plus operator. And then you have primitive values can be concatenated to string objects, converting them to string type. So basically the first one we know is true. I can do hi plus space, and that's going to give me a new string, which is hi, and then a space after it. Now, primitive types such as integers and doubles can be concatenated. That's also true. You can, for example, do hi plus 7, and that's going to give you hi 7. Okay? And then the next thing here is string objects are immutable. Now, we did not talk about mutability because this is something that is not necessarily as referenced. However, string objects are definitely immutable. Once you create an object, you cannot change the actual value. You cannot change the value of that text unless you completely create a new object to replace it. So therefore, the correct answer is 1, 2, and 3 because all of them are true. All right, so now on to number 11. It says, which of the following associations between escape characters and the purpose are false? So the first one is backslash quotes, allows for double quotes inside of string literals. That's true. Backslash allows for new lines. That is not true. Remember, new lines is I think it's for you, it would be this way. \n, okay? Now, a backslash allows you to actually add a actual backslash in your string. So that's incorrect. And then /n allows for tabs. That's incorrect. To allow for tabs, that will be /t. So therefore, 1 only is correct for this one. All right. Now moving on to number 12. Given any string, which index is located at the first character? Remember, first character. This is key. First character is 0 when you're talking about indexes. Let's say I have hello as my string, right? My first letter is at index 0. Then second at 1, 2, 3, 4, right? It's always 1 less. It starts at 0 always. Therefore, A is correct. Now, number 13, what is the output of the code below? So I have my string equals hello world. So I've created a new string object, which I've stored as a variable my string. And then I do system.out.println my string dot length. So this is using that method dot length. What does dot length do? It returns how many characters are actually inside my string. I look at my string and I can count 1, I'm going to make my pen a little bit smaller. 1, 2, 3, 4, 5, 6, 7. Remember, spaces count. 8, 9, 10, 11, 12, 13. There are 13 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Therefore, 13 will be the correct answer. Okay? Now, number 14, which is the output of the code below. Now, this is substring, right? From 1 to 2. Remember, the first value is inclusive, second is exclusive. So, and this is indexes. Index start at 0. So I start at index 1, right? Index 1 will be E, and I include that. But then I do not include 2, right? I do not include 2. Therefore, E is correct. B is the result of the print statement. 15, what is the output of the code below? You have hello world, and then you're now doing index of. So remember, index of returns the position, which is index, position, or the index of a certain string inside of the original string. The string that I'm trying to search for is a exclamation point. So I'm saying at what index position is my exclamation point? Well, let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is at the 12th index. Therefore, 12 is correct. Remember, it's not 13 because 13, it means that it starts at 1. It starts at 0. Indexes start at 0. Now we're going to move on to number 16. What is the output of the code below? And now it says compare to. Again, compare twos are very weird. It says, what is the output for the code below? String apple equals apple, string android equals android. And now I'm doing apple and I'm comparing it to android. So now what is it going to do? Right? When I have the apple, so I have apple, and I'm saying how is this different from android? So if the first letter is the same, it's actually going to compare the lengths. It's going to compare the lengths. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So this is going to be 2 less than this. And I think 2 is the correct answer. All right, now we're going to be talking about number 17. What is the output of the code below? And remember, I'm now creating a new variable, myDouble, with the type of double. So we're back in the primitive world here. And we now have math.pow23. So what does this do? It takes 2 to the power of 3. And this is going to return 8. But because my type is a double, it's going to give me 8.0, right? 8.0 because it is a double. Remember, the double representation of an integer has the number 0.0. So therefore, it will be, 8.0, which is B. Now we do 18, which of the code is not possible. I have math.random. Remember, it's between 0 and 1. Therefore, 1 is not allowed, right? It has 0 inclusive, 1 exclusive as what it can be in random. Therefore, 1 cannot be included. Now, number 19, what package are both the math and string class part of? This is going to be java.lang, right? Because it is part of the Java language. It's not part of the Java utilities and, packages, classes are not a thing. It is java.lang. And I talked about that in the beginning of part 2. Now, the last part, number 20, is about static methods. So 1, static methods are used on objects not initialized, right? That is true. In fact, let's go over to my example over here, right? I used literally the name of the object the name of the class .pow. I did not initialize. I did not create a physical math object. I just referred to a method from this class without actually creating an object of that class. Therefore, that is a static method, right? All of the methods from a string class are static. That is incorrect. All of the things from the math class are static. However, not the string class. So therefore, this is incorrect. And then only the random and POW methods from math class are static, the rest are not. That's also not true because you have dot, dot square root, right? Dot absolute value. These are all static. So therefore that's incorrect. And the correct answer is 1 only. So hopefully you did well on the multiple choice section. That is the end of section 1. It was not too bad in the sense that we pretty much talked about everything. The only weird ones were probably number 16 because, that had compare to, and compare to is really weird. And there'll be a complete separate video on compare to coming very soon. And then the other one will just be APIs because I did not specifically go over that. However, your teacher may have gone over that. All right. So now the next part is the free response question. This is the piece that is a little bit, this takes a little bit of thinking. So it says in the space below, design a class from scratch named car that contains the following fields. So you have make, which describes the brand name, model, which this actually should be lowercase. I think it just auto-completed as capital, should be lowercase. Describes the model name of the car. Is convertible, describes whether or not the car is a convertible. And num passengers describes the number of passengers. Now, when you're creating classes, I really recommend you do the following. You look at all of the fields and then you determine what type the field should be. Therefore, you know what you're creating. When I'm describing the brand name, that's going to be actual text. Therefore, this should be a string type. Right? When I'm describing the name, the model name of the car, that's also a string because that's a name. Now, whether or not the car is a convertible, it either is a convertible or it isn't. Yes, no, true, false. That is going to be a binary choice. That is a Boolean. And then lastly, the number of passengers. Now remember, we had a question about this earlier in Unit 1 about the airplane. Right? You usually don't want to have parts of passengers on a plane. Usually you're going to have whole people. Therefore, integer is the correct data type for this one. And of course, these should be lowercase. I'm just going to go with that so that we keep kind of continuity between what we're writing and the data types we're actually creating. All right? Then it says design and implement a constructor that takes in values and initializes them. Okay? And then describe and initialize the following fields. So we have add num passengers. This message adds the number of passengers passed in as parameters. And then this one, the method prints the make and model with the space separating them. All right. So it says you must use the appropriate keywords and fully complete the class to receive credit. And that's going to be on this page right here. So this defines the car type, right? Public class car, it gives you the header. On the AP exam, when you're writing classes or writing methods, it will give you the header. And there is going to be a question always on the free response of the FRQ. It's on the College Board's website. That will have you fully designing a class like this from scratch. So this is great practice in Unit 2 for the AP exam. So I'm going to do open and close parentheses. Right? And I can do close parentheses and then / class. And that's basically telling me, that's a comment saying that this is where my class ends. That way I don't get confused with a bunch of parentheses. So the first thing I'm going to do is I'm going to initialize my fields. Or not initialize, I'm going to create my fields. And remember, the keyword to use when creating fields is going to be the private keyword. Right? And I'm creating my first field, which is make. And I said already, and this is why it's so useful if you already write down the types of your variables. My type of make is going to be string. So I say private, then the type string, then I can write the name. The name is make. And then I just do semicolon. Remember, I don't have to initialize it because the constructor will do that for me. And then I have model, which is going to be private string, which is the type, and then model, which is the name. Okay? Now my third is going to be is convertible, and that's going to be a Boolean type. So I'll have private, right? And then Boolean, and I'll be using purple to specify because it's a primitive type. you know, just for color coding here. Sorry, I don't know what happened. Is convertible. All right. And then the last one is going to be an integer, number of passengers, or just num passengers. So I will do private, always private for fields. Int num passengers. Just like that, there you go. You've created your fields. Now you can create your methods. Actually, it says number 2 to create the constructor. So I'm just going to do it in order as it says. I'm going to create my constructor next. And the constructor will actually create, or it will initialize, or at the beginning, it's going to set the values for these 4 fields when the actual object is created. So to create a constructor, you always want to use the public keyword. Remember, always use public. And then I do public, and then the name of my variable. So this will be public car, right? I have open parentheses, and here I put my inputs, right? I put my inputs. So I'm going to have public, and then I'll have string mk. We'll say that's make, string mdl for model, and then I'll just go to second line here. Boolean for, you know, is C for is convertible, and then int num p for num passengers. And remember, for these, I have open and closed parentheses. So I'll have open and closed parentheses for my constructor. And then remember, I have to initialize my fields. So to initialize my fields, I do this, right? Dot the name of the field. So this dot make equals make. Now I'm constantly changing the colors so that you can kind of make connections. Greens are always my operators, right? So I have this dot make, and in fact, I'm just going to write all of them out. So I have this dot, and this dot. I'm just going to move my, you know, my brace a little bit down. And then I have model, I have is convertible, and I have number or num passengers. And then I have equals for both of these. And then I set this one equal to MDL because I'm passing in the model. Is C for is convertible, and num_p for number of passengers. And I'll have semicolons at the end of all of those. So that is my constructor. All right, now so now I'm going to be talking about the last part, which is my 2 methods. I'm going to move this down, right, because I want some space. So the first method, so I'll have methods. So the first method I'm going to create, remember, methods are also public, right? Generally, it's good convention to use public. So I'll say public, then the name of my method. So my first one's going to be add num passengers. Add num passengers. And then my input, which is actually specified right here, gives me the header. Int new passengers to add is what I have to put here. So I'm going to do int num passengers to add. And then I'll have open parentheses, close parentheses. And basically what this function does is it adds to the number of passengers that I have. So I will have this, remember I use this to refer to my methods, this dot num passengers. Now what operator am I going to use? I'm going to use my compound assignment operator, plus equals, which adds to a value and then sets it equal to. So I'm going to add number of passengers to add. So I'm literally going to take this here and I'm going to basically add this to number of passengers. Now, what is my last method? All right, let's see. Can I move this up a little bit? No, I can't really move it up. So I'm just going to extend a little bit down here. All right. So my last one is going to be public. Actually, I may be able to write it here. No, I'll just write it down here. That way its text is not covering it. So I have public. And then my last method is print make model. And you see here there are no parameters. So I do print make model, open and close parentheses. And because I don't have any inputs, I don't have to put any in there. And then what I do is I have my open. Actually, remember here, I need to add, I did this here, you may have caught me, I have to add the void keyword in my method because I'm not physically returning, I'm not actually returning anything. So you make sure you have to add public and then void. So public void, because I'm not returning anything, print make model. And then I have open parentheses, close parentheses, sorry about that, right? Well, now what does this do? I can read my description up here. It prints the make and then the model with a space in between. So I can simply go over here and do system.out.print line, open, close, right? And I can simply do this, right? Dot make plus, and then I have a string that's a space, right? Because I need to have a space, and then plus this dot model. So what happens is when I run a print make model, it's going to print out the make, then a space, then the model. That was a very long FRQ. Now, you will always have on the AP exam a FRQ that is related to creating a class. Everything from fields, constructor, methods. If you can already do this and do it well, you're already setting up for a very good foundation for that FRQ question. If you can create fields, create constructors, create methods. Because the funny thing is what a lot of people do is they'll answer it on the AP exam and they'll get actually the code right? Because when you do that more advanced logic, but they forget the basic structure of a class, how to create a class. If you remember these, right? Private for fields, public constructor. Remember constructor, you do not have to include void or any return because it just doesn't do that. And then for methods, you have public or private in very few cases, but generally public. Then the return type, void meaning that there is no return, and then the name of the function, the input, and then it does something. All right, so that is the entire practice test that I made for you. The answers to the multiple choice section 1 and for the FRQ. I hope this is helpful. If you have any questions, leave them in the comment section below. And please like and subscribe for more content. As always, thanks for watching, and I'll be back soon for Unit 3, Boolean expressions and if statements. Thanks for watching.